Hi again, welcome to the garage. I'm Pierre. Uh, Celebrating 5,000 subscribers. Oh, like just lately. So, guess the first people to be thanked for this is all of you people. I wouldn't do videos if it would be for empty chairs. So, you're there, you're liking, you're subscribing, you're commenting, you're supporting the channel. I mean, it is a great reward for me, and I'll keep on producing videos for you if you keep on liking it. My friend Philip, Robert, and the main three monkeys are joining together to say that we're happy to have you around and support our stupidities and stupid jokes once in a while. But that's part of the deal. Today's main subject now: resurrecting this defective vise. This is an Alltrade vise, the bigger format, and had some issues with it. Let's see how we can machine weld and bring that back to life. Let's go. It's been a while since I've been looking for this type of vise, which the bigger type, because there's one at Harbor Freight that sells, but it's quite smaller than this. The vise rotates 360 degrees here. There's an area there where you can catch a pipe, round parts, and I don't know if the previous owner just kind of knew and didn't mention it, but I'm stuck with a part that's kind of fully cracked here. Cleaned it up a little bit with the like a carbide burr into a die grinder. This is the front part of it. See the crack there? It goes down pretty far in there. Let's try to get a better angle of that crack. Let me get stable. And it's going at least there and almost that area there. So it's almost like 95 or 90% torn apart. Okay, this is the other side from the rear. The front crack goes right down in this area there. It's almost right through. So this is how bad it is. I mean, it's not gonna hold any normal use. This will have to be addressed. There are a few ways to address this. There's the pad way. Not the paper pad, but the paper edit design, which I'm better at this than I made all the drawing and everything. This, if I could go, let's say, sorry, on the machine, I could machine another one and make one. Quite time consuming though, and not too sure about one thing, because this thread here is Acme thread. It's number 5 Acme thread, and boring barred with the Acme 5 Acme thread that will fit in there is much of a problem. Here's the main reason why I wouldn't consider using an insert type tool for threading the Acme 5 thread, because Acme 5 thread comes into the IR22 size inserts, the one we mostly buy and purchase for our shops in the regular day-to-day use is the IR16, and there's quite a big difference between the two, and the holding tools are bigger. And what I would have to bore is very, very close from this bore here, and that don't even fit. So and I don't want to re-equip for once in one rare occurrence of a job. Second solution, I can make myself high-speed steel insert or kind of bar. Possible too. Will be able to fit in there. Also buy a huge tap, Acme tap with the specifications. I think it's 20-something millimeters with Acme 5. Expensive. I mean, they get you an arm and a leg for this. So for once in a lifetime use, at least expectable, I'm going to try to empty some of the metal there. This is cast iron. This is hopefully weldable cast iron. I will be preparing this and making a weld with high nickel content rods, especially made for those castings. Hope it works. If it doesn't work, still got my pad and maybe the high-speed insert. Wish me luck. Yeah, when starting a project, it's always preferable to have some kind of a plan. And the plan for this one is to get down there with an end mill, get about half the material that's on the support stem there, go down, and this will make some kind of a nice clean prep to allow me to fill up with some weld. I'm going to be using some high nickel deposition rods. They're especially meant for repairing cast iron. Since the stem there is not exactly at its place, it's been opened a little bit. The other part is going to be to whether to, it's going to have two purposes. This is going to hold this against the basic the base part there, and it's also going to give me pressure to put that back right in place. Okay, the main idea here is to take an end mill and start clearing some material in order to make me a good welding prep. I don't take my best end mill, my most expensive end mills to do this kind of shitty job, so a little bit of rubbing. That's alright, seems to be holding pretty good. Give it a little angle because the cracks are going a little bit in that direction, so going good. Okay, let's stop this. That's far enough. Let's see what we did. Okay, diffuse light goes better, less reflections. We see in there that it's pretty well eaten up. You even got some voids there. I think maybe the failure become from those voids. Probably, I'm not 100% sure, but this will give me a good prep to allow the weld to stick in there. Let's go heat this up and see how it's going to hold. This little plan we had at first is still holding pretty good, still keeping the gap closed and also keeping the part right at this rightful place. So I think the plan works well so far. So we're working about 347, 348. Temperatures kind of evening up. Some parts are a little bit warmer than others, but at least I got a few hundred degrees at the other end, so it's going to help a lot to keep the part just from cracking or anything like that. So this is a ceramic blanket that will help keep the heat inside. This is pretty hard to burn. These are rods meant for welding some cast iron. Let's see what it does. We'll be applying some thinner coats, and we'll be filling the gap, as we go. I think you got a better sight like this, but yeah, I know it's dark. I'll have to deflux, do a little bit of peening in there, and we'll go for another one. Okay, after some peening a little bit, had time to cool down a little bit though, but I'll try to catch it up and try to fill up from the back. And another little shot. I'm gonna go for another bead soon before it starts cooling down too much. This time from the front. Let's clean this up. Come on. Come on. That's gonna do. Those sticks have been used a little bit, so they're a little harder to start. It does a little bit like 7018. Okay, another bead done. Some cleaning up. Okay, I'm working my way by welding into this space. This here is not the weld that I had done lately. It's just the poor quality of the cast iron, and it's pretty porous. It's probably the reason why it just kind of cracked in the first place. What I did just before adding any other weld in there, I just grooved everything to make sure that I had no inclusion, no nothing. I'm going to add another, some more coats, clean up between the coats, cool down a little bit, warm up, cool down, and till I build up the this half there completely. So far it's going good. Just need to be, patient, and has to be like done in steps. See, I use the a ball. Let me show you. Here you go. This is a die grinder with a carbide little ball burr. It cleans up pretty good. One of the problems is the angle I get is not the greatest. This material is flowing pretty good though. Very close arc. Trying to get rid of the porous stuff, but not very good. Let this cool down slowly and see what it does. Okay, last bead for today. I've had it. We'll restart tomorrow. We're getting pretty full. The bad quality of the cast iron there just makes it more, let's say, volatile or things like. You see there that lots of voids in there. I think this cast iron is. Anyway, I hope I don't have to make another part though. But it's getting filled up pretty good. Like here we see that we're getting a pretty decent bead. We'll have to do some filing a little bit to make it pass into its space, and we'll see what it does. We'll do the other side tomorrow. Just a quick word to finish this up. I'll maybe get the TIG welding out with some Inconel rods to see if we can ever do some decent finish on this side. But first we have to mill the other side, empty it out, get it close to the other first beads. Hope it does good, because cast iron is a pretty finicky metal to work with when it comes to welding. So let's see what it does. Now ready to go for the second side. Notice that I gave it an angle, so I'm going to go to the bottom of the cracks there, trying to recuperate the the non-solidness of that part. And let's hope we're going to be able to dig enough material to replace by healthy material. I guess we see that there's still some way to go. What seems like a crack in the bottom and the side is a crack. So let's go. Let's dig in a little bit more. I think this end mill's pretty short, so I think we'll go for something new. Yeah, I kind of realized I was going to have a big problem doing this with normal end mill. Kind of got pretty short though. So there's a carbide end mill, not my best carbide end mill, but I'm going to do some of the rest of the work with this. Some stuff just got hard in there by the heat and the cooling and everything. This high carbon material is like that. Okay, now you're back in place. You probably see, let me grab a bloody thing, okay? The bottom there, big porosity. I mean, it's horrible how porous the material is. I mean, I can't believe how much shit comes out of there. Let's go finish this up. I think we need to clean up a little bit more of this. Yeah, I've been having a few tacks in there. I'll try to do another little adding. Oops, sticky. Oh boy. Gotta try to make it so there's no folds in the no inclusion. I've decided of a little change of technique here. I'm having some problems with the flux coming under and having to clean up and having to redo lots of grinding. So I have to practice my old first first love in welding, TIG welding. Yeah, back to it. I mean, love that technique. The only thing is, with age, I'm just getting better at sharpening tungstens. That's the main issue. Okay, let's go. And I'm not sure you're gonna be able to see everything I'm doing, but let's see what I can do. If you're not comfortable, you won't like your experience in TIG. Let's go. Let's try. See what it does. Oh boy. Not very easy to weld in the bottom of about an inch, 3/4 of an inch deep hole in there. It's gonna get there. I'm in my own way. Not bad, I'm getting there. There's a huge puddle down there. Oops. Tungsten sharpening again. Yeah, new TIG welding approach is helping somehow, because with the stick sometimes you make folds, and under those folds you say some flux is just getting there. So the let's say the puddle that I make with the stick, the TIG welding, which is kind of a wide surface, just turn it around, weld pretty good that everything melts together, and ended up like going to the center, and everything just mingles together and then ends up closing with a very good penetration in the bottom of the puddle too. So I think we'll finish this up with the TIG welding. It's I'm using some Inconel welding rods. This is the this is the nomination of the welding rods. Problem with poor quality cast iron, it just makes pretty shitty welds. And then when it's porous, just makes some micro explosions of air. Finally, it's back on. Would I consider this like a good Vise? Not really. Just advice, don't buy that. We noticed here that it was very hard to make a decent weld there, because blending the, let's say the nickel base rod or whatever with the sheety, it's very, very, very porous. Look at these are all pores into the. Hey, I think you can see this there too. Like it's just soft stuff. I mean, no wonder it broke in the first place. Would I consider this like a good Vise? I don't know if all the other ones are like that, but this one is shit. Also, would I buy another one? I would check it good before I ever buy anything like this again. As far as I'm concerned, I'm very disappointed of the quality of the material in there. Like, porous cast iron like this, trying to match with the high nickel content rods or whatever. I mean, it's almost impossible to make a nice job. It just like fizzles, and it doesn't go good. Like good cast iron will be much better. So would I recommend to buy some of these Vise? Not really. They're or check them good. But usually the main problem is they're going to be opening there or somewhere around this area. Is it working? Yeah, it does what it's supposed to do. It ties up, seems to be tying up pretty good. Rotates. I can place my part in just about any direction. Now, a little bit of tightening. It's holding good. Oops, I got a swivel base to make tight. No, it seems like it's in working condition. I don't know for how long. I hope it's going to last for a long time. Next time it breaks, am I going to get the trouble into just trying to repair that? I don't think so. It's gonna go direction garbage or scrap as soon as it breaks again. So check them out good if you buy them. But so far, a successful repair seems to be holding. For the anniversary of the 5,000 subscriptions, if you want to receive some stickers, just like complimentary stickers, I'm not charging for them. Send me an email. It's going to be in the description box. I'll send you one sticker of my channel, one sticker of Philip's channel, and that'll be some kind of a little, not a big treat, but something I can think that maybe it was going to be pleasant to someone that receives some. So just send me an email, like I say, with your mailing address, and I'll send you one of those.